Matrices are blocks of numbers made up of rows and columns. Equal matrices have the same dimensions, meaning their rows times their columns are the same. They have the same number of rows and the same number of columns. And the corresponding elements of each of the matrices is equal. Here are some examples of equal matrices. 4, 3, negative 2, 4, 3, negative 2 they're both 1 times 3. In other words, 1 row times 1, 2, 3 columns. 1 row times 1, 2, 3 columns, where rows is in red and columns is in blue. Here we have two other equal matrices, and these are both 2 by 3 matrices. 2 rows by 1, 2, 3 columns. 2 rows by 1, 2, 3 columns. They have the same rows times columns, and each element corresponds to another element, and these elements are all the same numbers. Two matrices, A and B, can be added if they have the same order. Add by adding corresponding elements. For example, here we have a 3 row by 2 column plus a 3 row by 2 column. Well, we can add these because they're of the same order. How do we add these? 3 plus 1, 5 plus 5, 2 plus 2, 6 plus a negative 1, 1 plus 4, 2 plus a negative 2. And we get this resulting vector here. Scalar multiplication of matrices. If we have K times capital A, that means multiply each element of matrix A times the scalar K. For example, if I have 4 outside this 2 by 2 matrix, I just have to do 4 times 2, 4 times 3, 4 times negative 1, and 4 times 4. Notice my matrix was order 2 by 2, and my resulting product matrix is also 2 by 2. I don't change the order there. When we talk of subtraction of matrices, what we have to do is consider that vector A minus vector B is the same as vector A plus the opposite of vector B. And then we subtract corresponding elements provided that both vectors A and B are of the same order. Here in this example we have a 2 by 3 minus a 2 by 3. They're of the same order, so we can do that. So this one is written again, matrix A is written again, and we distribute out this negative just like we're multiplying by a scalar negative 1. So this goes to negative 1, 2, negative 3, 6, negative 5, negative 2, and then just add the corresponding elements. So 6 minus 1 is 5, 1 plus 2 is 3, etc., etc., and you get this resulting matrix. Notice this is a 2 by 3, this is a 2 by 3, and this also is a 2 by 3. In a square matrix, the number of rows is equal to the number of columns. So for an n by n matrix, we have a square matrix of order n. On top here, we have a square matrix of order 2, or a 2 by 2 matrix, because we have 2 rows by 2 columns. There's rows by columns. And here, rows by columns, this is a square matrix of order 3, or a 3 by 3 matrix. Here's the number of rows, 1, 2, 3 rows, and 1, 2, 3 columns. 3 rows by 3 columns. In a zero matrix, every element of the matrix equals 0. The matrix can have any dimension. Here is a 0 matrix with 1 by 4 dimensions. And here is a 2 by 3 0 matrix. With our numbers, if we take a number like 4 and we add 0, we get 4, and that's called the additive identity. With matrices, we find the same thing. The additive identity matrix says that a matrix A plus 0 is the same as 0 plus matrix A, where 0 is the 0 matrix with the same order as A. For example, if A is defined as 4, 1, 2, 6, a 2 by 2 matrix, plus the 0 matrix, which is also 2 by 2, that's the same as saying the 0 matrix plus the 4, 1, 2, 6, 2 by 2 matrix. The additive inverse matrix brings us back to 0. So if I have a matrix A plus its additive inverse, I'll go back to 0. Or if I have the additive inverse plus A, I go back to 0. For example, for 2 by 2 matrices, if I have this matrix plus its opposite, so 4 goes to negative 4, 3 goes to negative 3, 2 goes to negative 2, 1 goes to negative 1, I'll wind up with my 0 matrix in a 2 by 2. Here's an example with matrices. It says find x, y, and z if matrix A equals matrix B, where matrix A is equal to this matrix and matrix B is equal to this matrix. Well, if we're going to set A equal to B, then we can set their elements equal to each other. 2x will equal x squared plus 1 So minus 2x from both sides, factor and solve, get x equals 1. Then y plus 1 is equal to 3, so obviously solve y is equal to 2. 3z minus 4 is equal to 5, so when you solve you get z is equal to 3. And z squared equals 9, take the square root of both sides, we get z is equal to plus or minus 3. So we have z plus or minus 3, y 2, and x 1. Using the fact that if the two matrices are equal and they're both 2 by 2s, upper left-hand corner is going to equal upper left-hand corner, upper right-hand corner equals upper right-hand corner, etc.